Hello everyone. Today we will going to see some practice questions from the chapter Biomolecule, and this is part 3. Let's start. Disclaimer. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So today we will going to see some practice questions from question number 17 to question number 24. Let's start with the question number 17. The secondary structure of a protein refers to. So we have given some options and you have to tell that the secondary structure of protein is referring to which of the correct options. So options are alpha helical backbone, hydrophobic interaction, sequence of alpha amino acids, or non-fixed configuration of polypeptide backbone. You have 10 seconds to think about this question. After that, we will see the correct answer. Okay, so let's see. The correct answer for the given question is option A, that is alpha helical backbone. Secondary structures involve alpha helical and beta pleated sheet-like structures. So in the secondary structure of proteins, alpha helical and beta pleated sheets-like structures are present. Alpha helix is formed when the chain of alpha amino acids coils as a right-hand screw, where in beta-plated sheets, the chains are held together by the large number of hydrogen bonds. So, secondary structures are made up of various alpha helical and beta-plated sheets like structure, and alpha helix is formed when so many amino acids chain coiled as a right-handed screw, whereas in the beta-plated sheet, the chains are held together by the large number of hydrogen bonding. That's why we have the correct statement, which is A. That means alpha helical backbone. Moving to our next question. Following amino acid has been found in the protein prothrombin, but remained undetected due to the formation of another common acid A. So we have given an amino acid which is found in the protein named prothrombin. You can see, and but it is not noticed as it is remains undetected due to the formation of another common acid which is named as A. We have to identify A. Options are NH3 positive, CH, COO negative, and on the CH we have CH2, CH2, CO negative. NH3 positive, CHCO negative. On the CH, we have CHCOO whole twice negative. NH2, CHCO negative. On the CH, we have CH2COH. Or NH2CHCOH. On the CH, we have COO2 negative whole twice. So you have 10 seconds to think about this question. After that, we will see the correct answer. Okay, let's see. The correct answer for the given question is option A. Another common acid which is denoted by A is NH3 positive, CH, CO negative, and on the CH we have CH2, CH2, COO negative. So basically the amino acid given which is present in the protein prothrombin is NH3 positive, CH, CO negative. On the CH we have CH2, CH, CO negative whole twice. So it is it forms another common acid after losing two molecules of CO2 and forms a common acid, which is our answer. That is NH3 positive, CHCO negative on the CH2, CH2CO negative. So our correct answer is option number A. Okay, let's move on to our next question. On hitting with concentrated HNO3, proteins give yellow color. So when we heat proteins with concentrated HNO3, it will give yellow color in the solution. So this test is called. So you have to tell the name of this test. Options are oxidizing test, xanthoprotic test, Hobbs test, or acid-base test. You have 10 seconds to think about this question. After that, we will see the answer. Okay, let's see. The correct answer for the given question is option B, that is xanthoprotic test. Xanthoprotic test involves heating of a protein with concentrated HNO3, which gives yellow color. It is used to detect amino acids containing an aromatic nucleus in a protein solution, which gives yellow color derivatives on heating with the concentrated nitric acid HNO3. The aromatic benzene ring undergoes nitration to give yellow colored product. So this is the whole mechanism which we perform in the xanthoprotic test. Okay. So giving a yellow color when protein heat with concentrated HNO3, the test is known as xanthoprotic test. And thus our correct answer is option number B, that is xanthoprotic test. Moving on to our next question. Enzyme trypsin converts. So we have given an enzyme which is trypsin. So you have to tell trypsin converts which into which. Okay, what into which? So options are proteins into alpha amino acids, starch into sugar, glucose into glycogen, or alpha amino acids into proteins. You have 10 seconds to think about this question. After that, we will see the correct answer. Let's see. So the correct answer for the given question is alpha proteins into alpha amino acids. So option A. Trypsin converts proteins into alpha amino acids. So trypsin is an enzyme which is used to convert the proteins into the respective alpha amino acids, or you can say protein into its constituents. Okay, so that's why we have our correct answer as option A, proteins into alpha amino acids. Moving on to our next question. Which of the following enzymes hydrolyzes triglycerides into fatty acids and glycerol? Again, now we have to tell that which enzyme we use for the hydrolyzation of triglycerides into the fatty acids and glycerol. Options are amylase, maltase, lipase, or pepsin. You have 10 seconds to think about this question. After that, we will see the correct answer. Let's see. The correct answer for the given question is option C, that is lipase. Lipase enzyme hydrolyzes triglycerides or lipids or oils and fats into fatty acids and glycerol. Amylase is hydrolytic enzyme of starch. Maltase is hydrolytic enzyme of maltose. Lipase is hydrolytic enzyme of lips, fats, and pepsin is hydrolytic enzyme of protein. So, the lipase enzyme hydrolyze our triglycerides into the fatty acids and glycerol respectively. All the other uh, enzymes we have given in the option have their own, hydrolysis, okay, mechanism. So every other enzyme hydrolyze a particular protein, but for triglycerides we use lipase enzyme to convert it or to hydrolyze it into fatty acids and glycerols. That is why we have our correct option as option C, that is lipase. Let's move on to the next question. Match the following enzymes with the reactions they catalyze. We have given a table in which enzymes and reactions are given in the two columns. We have enzymes as invertase, maltase, pepsin, or gymase. And in the reactions, we have conversion of glucose into ethanol, hydrolysis of maltose into glucose, hydrolysis of cane sugar, and hydrolysis of proteins into amino acids. You have to match the enzymes with the correct reactions they catalyze. Okay. Options are A2B1C4D3, A3B2C4D1, A1B4C2D3, or A4B2C3D1. You have 10 seconds to think about this question. After that, we will see the correct answer. Okay, let's see. The correct answer for the given question is option B, that is A3B2C4D1. Invertase, present as A enzyme, is an enzyme that catalyzes the hydrolysis of sucrose, that is cane sugar, into the glucose and fructose. So invertase hydrolyze sucrose into glucose and fructose. That's why A is connected with the third reaction, that is hydrolysis of cane sugar. Now maltase, as B enzyme maltase, is responsible for breaking down maltose or disaccharide into two molecules of glucose. So maltase break down the maltose into two molecules of glucose. That's why B is connected to the second reaction, that is hydrolysis of maltose into glucose. Pepsin, which is our C enzyme, pepsin. So pepsin is a digestive enzyme that catalyzes the hydrolysis of proteins into the smaller peptides. So when the proteins hydrolysis happen into the smaller peptides, the process of hydrolysis is catalyzed by the digestive enzyme, which is known as pepsin. That's why C is connected to the fourth reaction, that is hydrolysis of proteins into the amino acids. Zymase, or D enzyme zymase, is a complex of enzymes that catalyze the fermentation process, converting glucose into the ethyl alcohol or ethanol. That is why our D enzyme is directly connected to the first reaction, that is conversion of glucose into the ethanol. These are the enzymes, invertase, maltase, pepsin, and gymase, and they have connected to a particular reaction, the work they do, the reaction they do. Okay, that is why we have the correct answer as B option, A3B2C4D1. Moving on to our next question. Which of the vitamins given below is water soluble? You have to tell that from the options which vitamin is water soluble. Options are vitamin C, vitamin D, vitamin E, or vitamin D. Vitamin K, sorry. You have 10 seconds to think about this question. After that, we will see the answer. Okay, let's see. The correct answer for the given question is Option A, that is vitamin C. Vitamin B and vitamin C are water soluble, while vitamin A, D, E, and K are fat soluble or water insoluble. So there are two kinds of vitamins exist. First one is water soluble, which easily dissolve or soluble in the water. Another one is fat soluble, which is dissolved only in the fats and insoluble in the water. So vitamin B and vitamin C are the vitamins which are water soluble, while vitamin A, D, E, and K are fat soluble. And we have asked about the water soluble vitamins. So from the options, we have our correct answer as option A, that is vitamin C, which is a water soluble vitamin. Moving on to our next question. The vitamin which is water soluble and antioxidant. Now we have given two properties of a vitamin. You have to tell which vitamin from the options matches these two. Options are vitamin E, vitamin D, vitamin C, or vitamin B1. You have 10 seconds to think about this question. After that, we will see the answer. Let's see. The correct answer for the given question is option C, that is vitamin C. Vitamin C is water soluble. It also acts as an antioxidant. It is present in citrus fruits. So both the property of water soluble and antioxidant is existing in our vitamin C. That is why we have our correct answer as option C, that is vitamin C. Okay. Thank you.